Good morning, friends. Now I am going to discuss the fourth concepts, factors and multiples. What is a factor? The factor of a number is an exact divisor. It divides the number completely without any remainder. So, factor of a number is an exact divisor. Factor of a number is an exact divisor. Exact divisor means it divides the number completely without any remainder. For example, number 2 divides 6 completely without any remainder. The number 2 divides 6 completely without any remainder. So we call it as a factor. Therefore, we call 2 is a factor of 6. On the other hand, the reverse process, we call it as a multiple. What is multiple of a number? So the multiple of a number is a natural number which is divisible by the given number. So we need to find a number which is divisible by the given number. It's called multiple. For example, 6 is divisible by 2. 6 is divisible by 2. Therefore, we call it as 6 is the multiple of 2. 6 is the multiple of 2. Now we need to find out the factors of 6. Find all the factors of a number. So how do you find all the factors of a number? So we have a procedure to find the factors of a number. Let me write, and we know that it is a divisor. So 1 divides 6 exactly, 2 divides 6 exactly, 3 divides 6 exactly, 4 doesn't divide 6 exactly, 5 doesn't divide 6 exactly, 6 divides 6 exactly. So in order to find the factors of 6, we use the multiplication table. So 1 6 are 6, 1 divides 6, 6 also divides 6, 2 3s are 6, 2 divides 6, 3 also divides 6, and that's all. Because more than 6 doesn't divide 6. So first table, second table, second multiplication table, we can check whether we will get 6 or not. Third table, reverse process, it has come already, and 4 and 5 doesn't divide 6. So 6 divides 6 exactly. Therefore, the factors of 6 are, we need to start from here and write and complete round we make. So whatever the numbers are there in the product, all will be the factors of 6. So 1, 2, 3 and 6. These are the factors of 6. How do you find the multiples? Write first 5 multiples of 7. How do you write the multiples of 7? Again we use tables. So one table, 1 sevens are 7. 7 is divisible by 7. 2 into 7, 2 sevens are 14. 14 is also divisible by 7. 3 sevens are 21. 21 is also divisible by 7. Then 4 sevens are 28. 28 also divisible by 7. 5 sevens are 35. So 35 is also divisible by 7. So these are the first 5 multiples of 7. Therefore, what are the multiples? 7, 14, 21, 28 and 25 are the first 5 multiples of 7. So from this we can easily understand number of factors are finite and number of multiples are infinite. So we can have note of it. Note number of factors are finite. Number of multiples are infinite. Factors are smaller or less than. Factors are less than or equal to. Smaller than or equal to. Less than or equal to the given number. Multiples are greater than or equal to given number. Finite means we can able to count how many factors are there. Infinite we cannot count. Okay, uncountable multiples are there. And factor is always smaller than the given number or equal to the given number. Multiples are always greater than the given number or equal to the given number. These are the few facts about factors and multiples. Now, one more very important concept called prime number. So, what is a prime number? It's a very important number in mathematics, prime number. So, what is a prime number? We cannot divide this number by any other number. Prime number is not divisible by any number except the number 1 and itself. So, the natural number except 1 or other than 1. The natural number other than 1 which is divisible by 1 and itself only. The natural number other than 1 which is divisible by 1 and itself only and not divisible by any other number and not divisible by any other number. Is called a prime number. It's called a prime number. In other words, we can define prime number as the natural number which has exactly two factors. In other words, two distinct factors is called a prime number. So one way to understand prime number is the factors are 1 and the number itself, both are distinct, and we are not considering the number 1 as a prime number. So note, number 1 is not a prime number. The reason maybe the number 1 doesn't have two distinct factors. The number 1 is divisible by 1 and itself, but doesn't have two distinct factors. So the number 1 is not considered as a prime number. Can you able to write prime numbers? Let me write the prime numbers. The prime numbers less than, let me take 30. So up to 30 we will be considering which of the numbers are prime numbers. Certainly 1 is not a prime number. What about 2? You have to analyze the factors of 2. The factors are 1 and itself, both are two distinct factors, no other factors are there. So the number 2 is a prime number. What about number 3? Number 3 is divisible by 1 and itself. So it has only two factors, two distinct factors. So we call it as a prime number. Number 4 has 1 as a factor, 2 as a factor, 4 as a factor. So it has more than two factors. Okay, so it is not a prime number. In other words, number 4 is divisible by the number 2 also. Other than 1 and itself, it is divisible by 2 also. So 4 is not a prime number. 5 is a prime number. It is divisible by 1 and itself only. 6 is not a prime number. 7 is a prime number. 8 is not a prime number. 9 is not a prime number. 10 is not a prime number. So 11 is a prime number. 12 is not a prime. 13 is prime. 14, 15, 16 not a prime number. 17 is a prime number. Next is 19 is a prime number. 23 is a prime number. Then 24, 25, 26, 27 also divisible. So 29. These are the prime numbers less than 30. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So these are the numbers not divisible by any other numbers other than the number 1 and itself. In other words, these numbers have two distinct factors. That's why we call them as prime numbers. Let me move to another very important concept, LCM and HCF. LCM and HCF. What is LCM? Yeah, what is LCM? The expansion is lowest common multiple. Lowest common multiple or least common multiple. What is LCM? What is LCM actually? Only the expansion is least common multiple. It gives the meaning of LCM. It should be smallest and it should be common. It's a multiple of all these numbers and it is a multiple. Okay, first of all we should it should be a multiple and it should be there in all the numbers, and we need to choose the smallest multiple. In other words, I will say that LCM is the smallest multiple divisible by all the given numbers. LCM is the smallest multiple which is divisible by the given numbers. LCM is the smallest multiple which is divisible by the given numbers. For example, find the LCM of 12 and 18. How do you find the LCM of 12 and 18? So we need to look for multiples of these two numbers, and then it should be there in both the numbers, okay, and the smallest one we need to choose. So we have a prime factorization method to find the LCM of two numbers. We have prime factorization method. So we have to write both the numbers, just separating the two numbers with the comma, then divide only by prime numbers. Okay, the method is called prime factorization method. Prime factorization. Okay. So what is the first prime number? Just now we have seen prime number. First prime number is 2. 2 divides both the number. Okay. So how many times 2 will be there? So you can use long division. Long division, for example, 12 divided by 2. 12 divided by 2. How many 2's are there? You know that 6 2's are 12. Nothing remains. So instead of long divisions, we will be doing the division mentally and we will be writing it. 2 6 are 12. How many 2's are there in 12? 6. Then you put comma. How many 2's are there in 18? 9 2's are there. Again divide by 2. Even if one number goes with 2, that we need to complete it. So 3 2's are 6. 9 is not divisible by 2. You have to write as it is. Now both the numbers divisible by 3. So 1 3's are 3 3's are. Again divide by 3. 1 comma 1. So if it ends with 1 comma 1, you can stop and write the LCM. Therefore LCM is the all these prime factors you need to multiply it. So 2 into 2 into 3 into 3. So which is given by 2 2's are 4 3's are 12, 3 12's are 36 is the LCM. So what do you understand from this number? 36 is the smallest multiple. 36 is the smallest multiple of both the numbers. Okay, smallest multiple of both the numbers. In other words, 36 is the smallest number divisible by these two numbers. Okay, so 36 is the smallest, lowest number divisible by the given numbers. Next, HCF. HCF. The expansion is highest common factor. Highest common factor. In other words, we also call it as greatest common divisor. GCD, HCF, GCD, both are same. Highest common factor or greatest common divisor, both are same. So what is HCF? HCF is the greatest factor which divides the given numbers. HCF is the greatest number which divides the given numbers. For example, we will take two numbers. Find the HCF of maybe 12 and 18. How do you find the HCF of 12 and 80? So generally we use division method to find the HCF. So we need to divide the bigger number by the smaller number. So here the bigger number is 80 divided by the smaller number 12. Okay, so how many times 12 goes in 18? Just one times. So 1 12s are 12, then remainder is 6. Now it's a very important step. Remainder is 6. You take the remainder as divisor and the divisor as dividend, continue the division process. So you have to take 12 as dividend, divisor, previous divisor as dividend, and the remainder as divisor, continue the division process till you get remainder 0. So how many 6 are there? 2 6 are 12. Here we got the remainder 0. Okay, so if we do not get remainder 0, we need to continue the same process by taking the divisor as dividend and remainder as divisor. Continue the process till you get the remainder 0. And when you get the 0, then the last divisor is nothing but factor. This is HCF. Last divisor is HCF. Therefore, HCF of the two numbers 12 and 18 is just 6. Therefore, the HCF of 12 and 18 is 6. Okay, so we can also find the LCM and the HCF of more than two numbers. Let me take one more example. Find the LCM and the HCF of three numbers. 12, let me take 16 and 18. Okay, so how to find the LCM and HCF of three numbers? LCM, there is no problem. As usual, we can write all the three numbers separated by comma and use the prime factorization method. How many 2's are there in 12? 6 2's are there. How many 2's are there in 16? 8 2's are there. How many 2's are there in 18? 9 2's are there. Again divide by 2. 3 2's are 6. 4 2's are 8. 9 is not visible. Keep as it is. Again 2 because 4 goes with 2. 2 2's are 9. Again divide by 2. 3 1 9. Now none of the number is divisible by 2. Then take the next prime number 3. 1's are 3 3's are 9. Again 3's are 1's are 1's are 1's are 1 1 1. We stop the process and write the therefore LCM of these three numbers 12, 16 and 18 is equal to all these factors you have to multiply 2 into 2 into 2 into 3 into 3. So 2 2's are 4, 4 2's are 8, 8 2's are 16, 3 3's are 9. So 9 10's are 90, 9 6 are 54, 144. 9 6 are 54, 4, 5 remains. 1 9's are 9 plus 5, 144 is the LCM of three numbers. Now, how do you find the HCF of three numbers? Okay, so first we need to find the HCF of any two numbers. Okay, so you take any two numbers. Let me take 12 and 16 and find the HCF by division method. So bigger number is 16, smaller number is 12, divide it. How many times 12 goes? One time. 1 12s are 12, remainder is 4, and I told you we will continue this process by taking remainder as divisor and the divisor as dividend. Continue this process. How many times 4 goes? 3 4s are 12, so the remainder is 0. Therefore, this is the HCF for the first two number. Then next, you take that HCF. This is the HCF of two numbers. Take that HCF and divide the third number. Divide the third number, 18. So how many times 4 goes in 18? 4 fours are 16. The remainder is 2. Continue the process by taking the remainder as divisor and the divisor as dividend. Continue this. How many times 2 goes? So 2 2s are 4. So we have got 0. Now this is the number which is the HCF of all the three numbers. Therefore, we can write HCF of all the three numbers 12, 16 and 18 is equal to this number 2. I think factors, multiples, LCM and HCFs are clear to you. Still, once if you know the concepts, you can solve any type of problems. They will be asking questions. Find the smallest 3-digit number which is divisible by 3 numbers. Find the greatest, the smallest 3-digit number divisible by 3 number is LCM. And they may also ask, find the greatest 3-digit number which is divisible by the 3 numbers. Okay. So what we need to do, first you need to find the LCM of 3 numbers. If that LCM is not the greatest 3-digit number, you need to still take the multiples of that number till you get the greatest 3-digit number. I hope you can solve problems based on these concepts. Now the next concept, I will move on to the next concept, the sixth concept is, already we have seen 5 concepts. The sixth concept is decimal number. Okay, and the fundamental operations on the decimals and the fundamental operations on the decimals and fundamental operations on them. What is a decimal number? Decimal number consists of, what is a decimal number? Decimal number consists of 2 parts, whole and fractional part. Okay, so decimal number is a number consists of 2 parts, decimal part and the whole part. Separated by a point, called decimal point. Okay, so decimal numbers consist of 2 parts, whole part and decimal part or fractional part, separated by a decimal point. So in order to understand decimals and write decimals, we need place value chart. As we have seen in the whole numbers, we need place value chart to read and understand the numbers. Same way, we need a place value chart. Place value chart for decimals. Decimals. Okay. So two parts. One part is a decimal point. Okay. Here is I am taking a point. Point. This is decimal point. Decimal point. Decimal point. Okay. Then the first place is ones place. This is ones place. Whole part ones place. Then it comes tens place. Then it comes hundreds place. Then it comes thousands place. On the other side, this is tens. T-E-N-S, tens. This is hundreds. This is thousands. Thousands. Then immediately after the decimal point, we have tenth place. T-H-S, tens. Tens. It is 1/10 of a unit. 1/10 of a unit. 1/10 of a unit. Tens. The next place is hundreds. Hundreds. TH comes. Hundreds. Hundreds. Tens. It is 1/100 of a unit. 1/100. 1/100 of a unit. 1/100 of a unit. Then the next place is thousandth. Thousandth. TH. So it is 1,000 of a unit. So we will be using this place value chart to write decimal and understand that. For example, let me write 23.65. So here I have used 4 digits 2, 3, 6, 5 and separated by point called the decimal point. So from this what you understand? This is in the 10th, 100th place. 100th place. 5 is in the 100th place. Okay. This 6 is in the 10th place. This 3 is in the unit place, ones place. This 2 is in the tens place. So this is 5 hundredths, 5 hundredths, 6 tens, 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 th, 3 ones, 2 hundredths. See the difference between hundreds and hundredths. Hundreds is 100 things are there. 200s means 200 things are there. 500s means even we do not have one whole things. So a whole is divided into 100 equal parts. Out of that we have only 5. Very small number. Okay, the decimal part is less than 1. The decimal part is always smaller than 1 whole, smaller than 1. Decimal part is smaller than 1. So it is not 600s. 600 means 100 things are there. 500s means don't get, 500 things are there. Not even one whole things is there. Not even one whole thing is there. It is 500s. That means a whole is divided into 100 equal parts. We have only 5 parts with us. 5 hundreds, 6 tens, 3 ones and 2 hundreds. So, you know decimal numbers, place value chart you know very well. Now we are going to operate operations on decimals, operations. The first one is addition. So how do you find the sum of two decimals? It's very easy. While finding the sum of two decimals, we need to place the the digits according to their places and add them, add or subtract them, both one and the same. So addition of decimals, to add two decimal numbers, to add two decimals, we need to write the numbers one below the other. We need to write them one below the other, according, this is very important, according to their places and add them and all the corresponding places. So what we need to do to add two decimals, we need to write them one below the other, okay, one below the other according to their places and add them. For example, let me take two decimals, add 23.25 and 7.6. How do you add this? Answer, solution. First, write the first decimal number, then write the second decimal number below the first decimal. Here 7 is in the unit place. See the unit place here. This is the decimal point. Okay, decimal point. This is units, hundreds, tenth, hundreds. So how many units? 7 units. So you should write here 7. Unit place you should write 7, and 6 tenths place is here. So you can write here and add them. No tenths. If you want, we can put 0. No tenths. No hundreds either. We don't have. Okay, we don't have hundreds. So 5 plus 0, we add 5 hundreds as it is. 5 hundreds will be there. So here tenths, 6 tenths are there, 2 tenths are there, totally 6 plus 2, 8 tenths will be there. Then point, 7 plus 3, 10. 10 in one group of 10, that will go to the tens place. 2 plus 1, 3. This is how you need to add two decimals. Similarly, subtraction is also same. We need to write one below the other and we need to subtract it. So subtract, maybe the same number. I will take 7.6 from 23.25. How do you subtract it? As usual, we write the bigger one first. From this one, from this we need to subtract 7.6. Write units and tens. Subtract. As I told you, there is no hundreds. Hundreds 0. No tens. You can add 0 to it. Then we are here subtracting it. 5 hundreds. Here you no need to take any hundreds away. So as it is, 5 hundreds will be there. Now 2 tens are there. We need to take 6 tens. Only 2 are there. We need 6 tens. So what do you need to do? You convert this, ones is equal to 10 tenths. 1 ones is equal to 10 tenths. 1 ones is equal to 10 tenths. Okay, so 1, if we divide into 10 equal parts, we will be having 10 tenths. So 1 unit is equal to 10 tenths. So already 2 tenths are there, 10 plus 2, 12 tenths are there. You take away 6, remaining 6 will be there. So here 2 units are there, 7 units are there. We cannot take away 7 from 2. Again you take tenths. 1 tenth is equal to 10 units. So 10 plus 2, 12 units. Take out 7, 12 units. Take out 7. Remaining how many units will be there? 5. And 1 tenth will be there, 1 tenth. This is how you need to subtract 2 decimals. And the third operation is multiplication. Multiplication of decimal. Multiplication of decimals. It's very easy. So multiplication of decimals, we need to multiply them as whole numbers, just removing the decimal point. Okay, so if you want to multiply 2 decimals, remove the decimal points and treat them as whole numbers, multiply as whole numbers, then you need to place the decimal point. Okay, suppose we have factors and product. So count the number of decimal places in the factors, which is equal to number of decimal places in the product. So let me take with one examples. So multiply, suppose 26.5 and 7. Suppose 5. So how do you multiply? We need to first take them as whole numbers without a decimal point. So you take this number is 265. Okay, don't take decimal point, remove it, multiply with 7.5, multiply with 75. Okay, so take them as whole numbers, just removing the decimal point, multiply them. How do you multiply? 265 multiplied by 75. Okay, first units will multiply. 5 5s are 25, 2 goes to the tens, 5 6 are 30, 32, 3 goes to the hundreds. Okay, 5 2s are 10 plus 3, 13. Now we are multiplying by tens. 7 5s are 35, 3, 7 5s are 35, 3 goes to the tens place. 7 6 are 42 plus 3, 45, remaining 4, 2 7s are 14 plus 4, 18. 7 5s are 35, 3, 7 6 are 42 plus 3, 45, 4, 2 7s are 14 plus 4, 18. 5, 2 plus 5, 7, 5 plus 3, 8, 8 plus 1, 9, 1. So it's a big number. Okay, 19,875. So 265 into 75 is equal to 19,875. Now we need to place that decimal point. Now 26.5 into 7.5 is equal to, we write the same number. What is that number? 9875. Okay, and count the number of decimal places in the factors. Here is 1, here is 1, 1 plus 1, there are 2 decimal places. So in the product also you should have 2 decimal parts, 2 decimal places. So 1, 2, so you should place a point here. This is all. So here also 2 decimal places are there. So number of decimal places in the factors, there are 2 decimal places altogether, and in the product also you should have same number of decimal places. So multiplication of decimal is very easy. You treat them as whole numbers, multiply, and then place the decimal point just by following the rule. Number of decimal places in the product is equal to number of decimal places in the factors together. Then we move on to division of decimals. division of decimals. So division of decimal is little complicated. Okay, so the reason is we don't have a table for decimal numbers. So we have multiplication table for whole numbers, but we don't have tables for decimal number. So if you want to divide one decimal by another decimal, first step is you need to convert the divisor into a whole number. Okay, so first convert the divisor as whole numbers by shifting the decimal point. Okay, so in order to divide one decimal by another divisor, first step is you need to convert the divisor as whole number just by shifting the decimal point. Okay, so in order to balance the number, if you shift the point in the divisor, you have to shift the decimal point in the dividend also. For example, let us divide, suppose 1.50, okay, by 0.25. 1.50 by 0.25. So first step is, here the divisor is 1.50 divided by 0.25. How do you do this? Here the divisor is decimals, so we need to convert them into whole numbers by shifting the decimal point. So here I am going to shift 2 places, then it will become whole number. So if you shift 2 places in the divisor to the right, in the dividend also you need to shift 2 places to the right. Okay, so this problem is equivalent to 150 divided by 25. So in other words, you know decimals very well. 1 units are there, 5 tenths are there, 0 hundredths. Here 2 tenths, 5 hundredths. All together 1 unit is 10 tenths and 1 tenth is equal to 10 hundredths. All together we have 150 hundredths. 1.50 is equivalent to 150 hundredths. 0.25 is equivalent to 25 hundredths. So 150 hundredths, 25 hundredths. How many 25 hundredths are there? See, 1.50 is equivalent to 150 hundredths. And 0.25 is 25 hundredths. So in 150 hundredths, how many 25 hundredths are there? Just divide, you can easily get the answer. So let me divide 150 divided by 25. How many 25s are there? 0. 100 we cannot give. Tens. 5 are the 25 we cannot give. So all together 0, 0 actually 0, 1. Then 15 again 0, 15, 150. How many 25s are there in 150? We have 6. 25s are 150. Remainder is 0. Therefore, the answer is 150 by 25 is how many? 6. The answer is 6. That is 1.50 divided by 0.25 is equal to 6. So, how many 0.25s are there in 1.5? How many 0.25s are there in 1.50? 6. Okay. So, this is how you need to perform divisions. I hope you have understood the operation decimal number and operations on decimal number. So, we will move on to the next concept in the next video. Thank you all.